In 1507, a Portuguese soldier stationed on a small island in the Persian Gulf wrote a letter home to his wife in Lisbon. He described the island in only 3 sentences. The first said the water around it turned red when it rained. The second said there was a valley where no sound existed. The third sentence simply stated that he wanted to leave. He never sent that letter. It was found inside the walls of a fortress 500 years later, still sealed. The soldier had arrived in this remote corner of the world with the fleet of Afonso de Albuquerque, the Portuguese commander who had decided that whoever controlled this small piece of rock in the middle of the Persian Gulf would control the trade between East and West. And what Albuquerque chose to build on that rock was a fortress directly on top of salt. The entire island was a giant salt dome, a colossal mass of minerals and rock that had been pushing itself upward from the ocean floor for 600 million years. The ground beneath those men's feet dissolved whenever the rare rains fell. The stone walls they raised during the day cracked during the night. Metal tools left outside rusted within hours from the extreme salinity in the air. The water they drank had to be shipped in from the mainland because nothing on the island was drinkable. The soil beneath their boots was the color of blood, deep crimson, stained by iron deposits, so concentrated that when rain struck the earth and ran toward the sea, the water along the entire coastline turned red. And here is the first thing that 500 years of engineering has failed to fully explain. Those walls, built in 1507 on a foundation of dissolving salt, are still standing today, facing the Gulf. Modern structural engineers who have visited the site say they do not fully understand how this is possible. Salt shifts under pressure. Salt dissolves with humidity. It is among the least stable foundations a heavy stone structure can have anywhere on Earth. And yet the Portuguese fortress on Hormuz has outlasted the empire that built it, the Persian rulers who reclaimed it, and the British forces who occupied it centuries later. It is older than most nations currently on the map. But the fortress was not the strangest thing about this place. The strangest part began when men moved away from the shoreline and walked deeper into the heart of the island. If you find yourself drawn to places where science runs out of easy answers, subscribe to the channel now. Every week we go somewhere the maps mark as known, but the evidence suggests otherwise. To understand what is happening on this fragment of rock, it helps to understand what it actually is beneath the surface. 600 million years ago, the evaporation of ancient shallow seas left behind enormous layers of salt, buried under subsequent sediment and volcanic rock across what is now the Persian Gulf region. Under the weight of the crust accumulating above it, that salt began to behave differently from ordinary rock. It became buoyant. It started to move upward through any weakness it could find in the layers above it, slowly and relentlessly, over millions of years, piercing through the earth like a column rising toward the surface. The result of that process emerged from the water barely 50,000 years ago, exposing to open air a mineral core that had spent hundreds of millions of years in complete darkness under the ocean floor. Walking toward the southern part of the island today, the landscape loses any familiar quality. The terrain becomes a series of actual glaciers made entirely of exposed rock salt, towering dozens of meters high, deforming slowly under their own weight and forming sharp white ridges that crunch underfoot in the heat. The ground is an active geological process, happening in real time. The island is still rising. The salt is still moving. What visitors walk on today is different from what existed 50 years ago, and what exists today will be different again in another 50. The layer covering that salt core is where the first direct mystery appears. Across most of the planet, soil presents in shades of brown, black, or clay. On Hormuz, the ground is a deep crimson red, so intense that visitors consistently describe it as appearing artificial, as though something had been deliberately painted across the landscape. Geologists have analyzed this soil and traced the color to an extreme concentration of hematite, an iron oxide that became embedded in the salt dome as it rose through ancient volcanic deposits over millions of years. The mineral content is unlike anything found in comparable geological formations anywhere else in the Persian Gulf region. More than 70 distinct minerals compressed into 42 square kilometers of island, including compounds that, according to standard geological models, require environmental conditions that are mutually exclusive. Some of those minerals form only under extreme heat and pressure at volcanic depths. Others require slow, stable, low-temperature marine environments over long periods. The conditions that produce one should eliminate the conditions that produce the other. On Hormuz, both are present in the same ground. When researchers have asked how this is possible, the answer from the geological community has remained consistent for decades. The full explanation is still being developed. What makes this iron-saturated soil singular beyond its color is something that contradicts basic assumptions about mineral toxicity. Iron oxide accumulations found elsewhere on the planet are typically laced with heavy metals and acidic compounds that make them harmful to consume. The red soil of Hormuz contains none of those elements in dangerous concentrations. The island's inhabitants discovered this at some point, so far back in their history that no written record captures the moment they began eating it. The locals climb the red hillsides, select the finest veins of the mineral powder, and grind it into a spice used in the preparation of sura, a traditional fermented fish sauce made with sardines, bitter orange peel, and this crimson earth left to mature in clay jars under the sun for months. They also incorporate it into tamshi, a local flatbread that emerges dyed a reddish hue with a metallic saline flavor. In an environment where conventional agriculture is chemically impossible due to the composition of the soil, the population developed a cuisine built around eating the ground itself. That adaptation has no parallel in any other inhabited place on Earth. The geology of this environment reserves its most dramatic display for the moments when rain arrives. Storms in this region are infrequent, but when they occur, they release extreme volumes of water in a short time, over terrain that has no capacity to absorb it. The density of the mineral components prevents infiltration. The absence of significant vegetation means there are no root systems to hold the surface together. When raindrops strike the red hills, the water immediately begins dissolving the hematite layer and carrying it downward in fast-moving streams that turn deep crimson within seconds of forming. These temporary rivers of red water rush down the cliffs and reach the shoreline carrying enormous quantities of iron oxide in suspension. When that mineral-laden water meets the sea, it does not immediately dilute. The density difference between the sediment-heavy runoff and the salt water causes the red layer to spread outward across the surface of the Gulf, staining the coastline for hundreds of meters in every direction. During and after these storms, the beaches and the shallow coastal waters turn a red so deep and uniform that the visual effect is one of the coastline bleeding into the sea. Ancient maritime texts from traders who passed through the Strait of Hormuz described seeing the island surrounded by red water and noting it in their records as a navigational marker. The phenomenon was reliable enough to be useful for orientation at sea. It is still occurring today exactly as those traders described it centuries ago. In the center of the island, the terrain opens into a canyon where something happens that has no straightforward acoustic explanation. Sound stops. This is not a description of a quiet location. The valley in the interior of Hormuz is a place where acoustic vibration appears to cease functioning according to normal physical principles. There are no birds in this zone. The wind, which moves freely across every other part of the island, loses its audible presence when it enters this area. The sound of the waves, which should be clearly audible given that the sea is never more than a few hundred meters away in any direction on an island of this size, disappears entirely at the canyon floor. People who have walked through it describe a sensation of pressure inside the ears, similar to the feeling of altitude change in an aircraft, as though the air itself has a different density. Breathing and heartbeat become the dominant sounds the visitor can perceive, amplified by the absence of anything external. Any sound projected outward, a voice, a clap, the scrape of boots on salt rock, fails to produce an echo and seems to be absorbed immediately by the mineral walls before it can travel any distance. The local population has known about this valley for as long as their oral history extends. Their name for it translates approximately as the place that swallows sound. Fishermen whose families have lived on Hormuz for generations historically avoided the area, and the tradition of keeping distance from it predates any contact with outside cultures that might have introduced the idea of the supernatural. The Portuguese soldiers who garrisoned the fortress in the 16th century were told about the valley by local guides, and some of them recorded their experience of walking through it in the few written accounts that survive from that period. The sealed letter found in the fortress walls mentioned it in one sentence. The soldier who wrote it did not describe what he saw there. He wrote only that he had gone in alone and would not do so again. The scientific explanation for the silence involves the porosity of salt formations and the particular geometry of the canyon walls, absorbing rather than reflecting sound waves. That explanation is accepted within the relevant fields. What it does not account for is why the effect is so complete, or why it occurs specifically in this location and not in the other salt formations that cover substantial portions of the island. Beyond the canyon, the ground becomes what geologists who specialize in mineralogy describe as one of the most concentrated and diverse surface mineral displays found anywhere on the planet. Walking along the interior trails of Hormuz, the soil changes color every few meters. White gypsum gives way to yellow sulfur deposits, which transition into bands of orange, then green, then a turquoise blue that appears in veins running through otherwise red rock, then gold-tinted formations that reflect the afternoon sun with a metallic quality. The chromatic variety in such a small area has no geological precedent in comparable formations. Each mineral present requires different conditions to form, and the standard models used to explain sedimentary and volcanic geology do not produce a satisfying account of how all of them ended up on the same island without destroying or altering each other during the millions of years of geological activity that shaped the dome. At the southern coastline, the ground transitions to what is known locally as Silver Beach. The sand here contains pulverized magnetite and hematite ore in concentrations high enough that the beach surface reflects sunlight with a metallic brilliance visible from a significant distance offshore. Walking on it, the ground glints and shimmers underfoot as the waves move the metallite particles continuously across the surface. The visual effect under direct sunlight is of a beach made of crushed metal rather than mineral sand. Ancient navigation charts of the Persian Gulf included this beach as a landmark, referenced by its appearance from the water as a surface that caught the light differently from any other coastline in the region. After dark, the coastline transforms again. The waters around Hormuz contain high concentrations of bioluminescent phytoplankton that emit light when disturbed by wave movement. This phenomenon occurs in various locations across the world's oceans, but the version that appears on Hormuz has a quality found nowhere else. The sand on the beaches retains the dark red tint of the iron oxide minerals throughout the night, and when the bioluminescent water washes over that crimson surface and retreats, it leaves behind a trail of cold blue light moving across red ground. The contrast between the neon blue of the organisms and the blood red of the mineral sand produces a visual combination that has no equivalent in any other coastal environment on Earth. Fishermen working at night along the shoreline for generations have described the experience in terms that were recorded by visitors from outside the region who could not find adequate language in their own traditions to categorize what they were seeing. The man-made structures on the island absorbed the same qualities as the environment that surrounded them. The fortress built by the Portuguese in 1507 was constructed from the island's own red stone, quarried from the same iron-saturated deposits that color the hillsides. The walls have taken on a deeper rust tone over the 5 centuries since their construction, darkening as the mineral content in the stone has continued reacting with the air and humidity of the Gulf. Beneath the fortress and extending into the salt dome below, it runs a network of underground passages constructed during the period of Portuguese occupation. These tunnels served as powder magazines, insulated from the extreme daytime heat that would otherwise have risked igniting the stored gunpowder. They also functioned as vaults for the customs revenues collected from the trade passing through the strait, with labyrinthine layouts designed to disorient any intruder who managed to breach the outer defenses. Some passages extend to exits at sea level among the cliff rocks on the northern coast, designed for resupply and evacuation during sieges. Descending into these corridors today, the air becomes dense with the smell of saltpeter, and the walls show the salt dome pushing upward through the stone construction, bowing the ceilings and cracking the mortar in patterns that follow the movement of the geological mass below. The fortress is being slowly consumed by the same material it was built upon. When all of these elements are considered together, what becomes difficult to resolve is the question of convergence. Standard geological science explains each feature of Hormuz in isolation. The red color is hematite. The silence is salt porosity. The blue light at night is phytoplankton. The mineral diversity is the result of the dome's long ascent through different geological layers. Each individual explanation is technically sound. What none of those explanations addresses is why every one of these extreme phenomena converged on this exact location: the edible soil, the beaches that reflect like metal, the valley where sound ceases, the coastline that turns red in rain, the water that glows blue at night against red sand. Individually, each of these would make any location on Earth remarkable. On Hormuz, they exist simultaneously within 42 square kilometers of salt and iron, rising slowly from the floor of the Persian Gulf. Ancient mariners used the island's changing colors as a navigation tool, which means the phenomena were consistent enough over centuries to be reliable. The oral traditions of the local population treat the island's behavior as a series of permanent conditions rather than unusual events, which means these things have been occurring for longer than any living memory extends. The geological record indicates the dome has been active and changing for hundreds of millions of years and continues changing today. The Portuguese soldier who wrote that sealed letter and chose never to send it had been to India, to East Africa, and across the Atlantic before arriving on this island. He had seen the coastlines of 3 continents and the interiors of territories that most people in Europe at that time had never heard of. He chose to describe this island in 3 sentences. The water turned red. A valley had no sound. He wanted to leave. He stayed for 8 months. The fortress required it. When the garrison was eventually rotated and he returned to the mainland, no record exists of him describing the island to anyone who wrote it down. The letter remained sealed inside the wall where it had been placed, in a building constructed on dissolving salt that should have collapsed centuries ago. and has not. The island is still there. The salt is still rising. The soil is still red. When it rains, the sea still turns crimson along the entire coastline. In the center, the valley still swallows sound. At night, the waves still carry blue light across red sand. Whatever the Portuguese soldier decided he did not want to put into writing, the island has continued demonstrating it to every person who has visited since. The geological explanations are available, well documented and technically accurate. They describe what is happening. They have not yet fully explained why it is all happening here, in this exact configuration, on this specific fragment of salt that rose from the ocean floor and refuses, after 600 million years, to stop moving.